be like a little easy for you. If you didn't attend it, like it is little difficult when we are solving the problems on one function. So like the definition of onto function we are seeing. Give me a moment. Let me change the color of pen. Onto function is also called as surjective function. We say a function f defined from A to B, A and B are two non-empty sets. As onto function, if every element of B has at least one preimage. What does this mean? Any element, if I take from set B, it has at least one preimage, is what this says, the onto function, right? Another words are like another definition, what we will also say is like F is onto if the codomain of the set, if the codomain of the function is equals to a range. For any function, codomain is equals to range, then that is onto function, right? Let us take a small example on two small sets. A is equals 1, 2, 3, 4, and B is equals P, Q, and then R. 3 we are taking. Let us define different functions on these two sets, and then let us try to understand what is onto and what is not onto. So like we say function f1 defined from A to B here. Let us write in this way 1, 2, 3, 4. This is P, Q, and R. So random mapping we are doing here. We can see here this function f1 is not onto. If f1 is not onto, we'll call that one as into function. Reason because it is not onto, there is an element R which does not have any pre-image in set A. We need to make sure whether like every element from set B has at least one pre-image or not, right? So like next let us take two different again a second function f2 on same sets. Now in this case let us write 1, 2, 3, 4, and then P, Q, R here. So mappings again we are doing in this way. So in this mapping I can see that like P has one preimage, and then Q has two preimages, R has one preimage, so we call F2 is onto function. This is the definition of onto function and the examples on that. Second definition is what we will use. If codomain of any set of any function is equals to range, that is onto function. Copy this one. Maybe you want like this general examples like let us take like function f defined from real to real, f of x is equals to x cube. So like we say this is one example of onto function because like the range of the x cube is minus infinity to plus infinity. The second thing I can say that f of x is equals to tan x or cot x also I can take. This is also not onto function. Third is like let us take f of x is equals to log x. Base is e we can call like again a range of log x is minus infinity to plus infinity. That's why it is onto function. Any doubts in this? Anybody?
No, sir.
Then you can copy this. Mm. Please do let me know once you copy this one.
Completed, sir.
Then we are going. Now we will solve the problems in the previous slide. Pay attention if you didn't attended the last class. Little trickier for you. You should listen carefully. So first problem in this is like 12th one. This is from your book only or I have kept anyway here. No need to refer any book. Read the problem here. Then see the options carefully. After that, we will understand like what they are asking and how we should do. If you see the problem, they have given function f is defined from real numbers to real numbers. F of x is equals to x minus 1 into x minus 2 into x minus 3. If I multiply this, I'll get x cube minus 6x square plus 11x minus 6, I guess. One is working, huh? One is working. This is what I get if I multiply. Give me a moment. What is this? Okay, perfect. There are some offline students. For them, I passed a little bit. This is what the function given here, that is like x minus 1, x minus 2, x minus 3. I multiplied and I wrote. This is not difficult and all. You itself can do direct multiplication, or you can use like the properties of cubic equation and you can write. So like first I need to check whether it is 1 1 or not. And then second thing I need to take in is like whether it is on 2 or not. Options are like asking 1 1 but not on 2 but not 1 1, both 1 1 and on 2, neither 1 1 nor on 2 it is saying. So like there is a technique what we calculus method we will use to check whether it is 1 1 or not. To do that one, like what we should find first derivative and we need to check whether the given function is increasing or decreasing in the domain. Clear? So like we are finding f dash of x here. F dash of x is equals to 3x square minus 12 into x plus 11 we have. Right? So next, after finding f dash of x, we will equate that to 0 and we'll find the stationary values where first derivative is 0. If I do that, I'll get 3x square minus 12 into x plus 11 is equals to 0. Now let us calculate the roots of this quadratic equation using quadratic formula. I guess can we split the middle term guys here? I think like 33. Some I need minus 12. I don't think I have anything. What do you guys think here? 33. Can we split middle term here?
No, sir.
No, then quadratic formula only we should use. X is equals to 12 plus minus 144 minus 4 into 33 divided by 2a we have. 2a
Sir,
is 2
isn't
3
it
sir.
minus 12 plus or minus?
No, minus b we should write, no? Minus b is plus 12
Okay.
only here. So this is 12 plus minus from 144 we are removing like 33 into 4. 33 into 4 na 112 4 3s are 12 4 okay 132 we are removing, so we have root 12 divided by 6. So how much is this? It seems 2 plus minus we will get 2 from this 1 by 3 into a root 3. So I have the roots here. What are those roots here? One root is 2 plus a root 1 by root 3. Another is 2 minus 1 by root 3. Whatever it is, 2 minus 1 by root 3. Now listen to me carefully. We are assuming like one root as alpha. Alpha is 2 minus 1 by root 3. Another root is beta. Beta is 2 plus 1 by root 3. Now drawing the number line, this is wavy curvy method we use like to check the sign here. So like this is alpha, this is a beta, right? I need to check the sign for f dash, not for f. Keep that one in mind. I can write f dash of x is equals to x minus alpha into x minus beta, where alpha and beta is like above here. Now, if I take any value, like this method says take any value less than alpha, check the sign, take any value in between alpha and beta, check the sign, and then take any value greater than beta. I can see like alpha is 2 minus something, right? So I am assuming like let us take 1 here. I am calculating sign of f dash of 1. Positive, negative will do. F dash of 1 sign if I want, that will be equals to 3 minus 12 plus 11. Using this equation I wrote here, right? So now how much is this? I think it is like greater than 0. Positive thing here, right? So positive means writing positive here, right? So next again you take any value in between these two. I can see any value if I want, that is 2 only. One is 2 minus, another is 2 plus. Now take 2 here. How much is f dash of 2? This will be 3 into 4 minus 12 2s are 24 plus 11 here. We have like 12 plus 11 minus 24. We have minus 23. That is less than 0, writing minus in this. Now next we are taking any value greater than 2 plus 1 by root 3. We can use 3 here. F dash of 3 will be equals to, we get like 3 into 9 27 minus 12 3s are 36 plus 11 here. How much is this? We get like plus 2, I guess. Plus 2 is again positive, right? Now I can conclude that function is increasing till alpha. In this interval, it is increasing. From alpha till beta, function is decreasing. Next, from beta onwards, again, function is increasing. In the domain, I mean, in set for all real values, we cannot say function is fully increasing or fully decreasing. If situation like this arises, in that case, the given function is not 1, 1. We will call not 1, 1 means that is many one function. Clear? Understood? Right? This is how I will do to check one nature of a function using calculus method. Clear? So I need to check whether it is increasing or not, decreasing or not throughout the domain, not in the interval. Clear? So now I can see that clearly it is not 1, 1. So I can discard option 1 and option 4 after this. Now, next to do this onto thing, what I will do here is like whenever we have a cubic equation, always remember this. A cubic equation, if we have, in general, I am taking this is like you can read as a note point or point to be noted. Let's say we have a cubic equation f of x is equals to ax cube plus bx square plus c into x plus d, where a, b, c, d all are real numbers, and then a is non-zero real number. Right? A is not equals to a 0. If you have something like this, for this function, a range will be equals to always minus infinity to plus infinity. We can see that by graph, right? So whatever real number you have, that real number we will get at least once. Like what do I mean? Like you take any real number for a cubic equation. For example, I am taking like x cube graph. If we are taking x cube graph, we will be having like something like this. One moment. Right? So this x cube graph will attain every real number. Like you take any real number y equals something, it will attain at least once. Right? So like if you remember this note point, using this, you can clearly say that codomain is equals to range. If codomain is equals to range, we can say the function is onto function. Right? Now the correct option we need to pick here is like the second one, that is onto but not 1 1. Clear? Any doubt in this? Anybody?
No, sir.
Thank you for
No, sir.
responding. Okay, thank you for responding. Yes, yes. I have told no here, the function we'll say as 1 1. Did you attended the last class? So like here we wrote no. You can see the definition on my screen. Differentiation method we are using. If the function is strictly increasing, like if f dash of x is greater than or equals to 0 for all x belongs to domain of the function, then it is 1 1. At the same time, if it is not greater than 0, then it should be less than 0 for all x belongs domain of the function, then it is 1 1. Clearly I can see that like here the given function is not always greater than or not always less than, right? Using differentiation method I can say that the function is entirely not increasing or entirely not decreasing in the domain, therefore it is many one function. We have another argument as well. Give me a moment. In this argument we need to draw the graph. If you know this wavy curvy method, using that we can draw here, like to draw the graph of like f of x is equals to x minus 1 into x minus 2 into x minus 3. I am drawing like this, x and y axis. This is x is equals to 1, this is x is equals to 2 here, and then like we will be having x is equals to 3 here. Using the sign scheme method of the wavy curvy method we are doing, that is like you take any value less than 1, in between 1 and 2, in between 2 and 3, greater than 3. First mark the signs, then I'll tell you how to draw the graph. Let us say like I'm taking 0, f of 0 I'm getting here as negative or positive. How much is f of 0 here? F of 0 is minus 1 into minus 2 into minus 3, negative. So I wrote negative symbol here, right? So next we are taking any value in between 1 and 2, like 1.5 we are taking. If you take 1.5, 1.5 minus 1 is positive, right? So 1.5 minus 2 is negative. 1.5 minus 3 is again negative. So the resultant will be positive here. Right now take any value, like what we are taking, f of 2.5 I am taking, like f of 2.5 if I need, this is positive here and then again positive, the last one is negative. Now the resultant will be negative here. Now at the same time you take f of 4 or 3.5 and calculate the sign again. You will get positive sign. Once you finish this marking the sign thing, like listen carefully, this is positive again. Now our graph, x cube graph, will start from negative side. It will be always starting from minus infinity and it cuts the x-axis at x is equals to 1, right? So like I'm trying to draw a graph which is like cutting the x-axis at x is equals to 1, at x is equals to 2, and at x is equals to 3, something like this. This is not exact one, the approximation. Clear? Now using the horizontal line test, right? If I draw a horizontal line here, I can see that this horizontal line either should intersect at 1 point or 0 points, right? Right? Now I can see it is like 1, 2, 3 point of intersection. It says for 3 distinct elements, we have only one image. Therefore, the given function cannot be one function. It is a many one function. Any doubts in this?
Sir,
Yes,
sir,
please. Somebody. Yes, please.
sir, the note cubic
Ah,
equation is only for proving the onto function, sir.
yes, onto function.
Okay, sir.
You can write this is like for every cubic equation, a range will be minus infinity to plus infinity if the domain is real numbers.
Okay, sir. Thank you, sir.
Thank you, boss. Please copy this one quickly. We'll move to the next problem. Your friend only. Upward symbol stands for increasing. Downward symbol stands for decreasing. Function should not have both the natures in the domain. If it is having both the natures, then it is not 1.
Sir, it is f dash of x only, no?
No, sign is for f dash, but nature is for function. Here,
Okay, sir.
see, like f dash is less than 0 implies that f of x is decreasing. Here, f dash of x is greater than 0 implies that f of x is increasing.
Okay, sir.
Hmm. Any other doubts? Everybody copied this? Dear online students, copied this?
Yes, sir.
Yes, sir.
Okay, thank you. So this is the next problem. This is from our book only. Majority are from our book only. In this problem, they have given like you can see the problem once. According to the problem, they are asking like f maps real to real. Function f of x is given such that in options they have given like f of x is many one in the interval minus infinity to minus 1. Second option saying f of x is 1 in the interval 1 to infinity but not in minus infinity to plus infinity. The last one f of x is many one in 1 to infinity. Last fourth is f of x is 1, right? See, like I am going to use the calculus method here, guys. Listen, like whatever doubts you have in the calculus method, everything should go after this problem. They have given that in the problem, function f of x is equals to x square plus 2x plus 1 divided by x square plus 1 with us. Now, what I am doing, like I am differentiating here in calculus method. The first thing is like I should differentiate and I should find stationary values, right? So u by v, a rule of differentiation, quotient rule. This will be x square plus 1 into 2x plus 2 minus 1 into x square plus 2x plus 1 into 2x divided by the denominator is x square plus 1 whole square. Let us simplify the numerator 1. What we will get 2 times of x cube plus 2 times of x square plus 2x plus 2 minus we are subtracting. What is this? This is 2 times of x cube plus 4 times of x square plus 2x. What is happening the moment we open the bracket? I think some plus and minus terms will get cancelled. What and all. This 2 gone. And then like plus 2x minus 2x gone. The remaining thing maybe this side we are using f dash of x is equals to 2x square minus 4x square, that is minus 2x square plus 2 divided by x square plus 1 whole square. Maybe f dash of x is equals to taking 2 common 1 minus x square by x square plus 1 whole square. Now I have the derivative of the function. Right, after finding the derivative of the function, equate the first derivative to 0. Like again, listen, there is like functions, you take the quadratic equation only. Let us take a downward parabola. This downward parabola, if we observe carefully, like this is the vertex of the parabola. Maybe you call x is equals to c point, right? So let us take two values, like maybe this is x and y axis you can draw here, right? So x and y axis we have drawn. First, let us try to understand what is increasing. This is x1 and this is x2. On x-axis, if I see, there are like somewhere here, this is point x1, this is point x2. Now, on y-axis, this will be f of x1, and then like this is f of x2 over here on y-axis. Now, if you observe carefully, I can say that x1 value is less than x2. From x1 to x2, I increase the value of x. When you increase the value of x, function value should increase. Then it is increasing function. When you decrease the value of x, function value should decrease. That is increasing function. What is happening in value of x? Same thing should happen in value of function as well. Then it is increasing function. If it is happening opposite, that is decreasing function. Clear? I can clearly see no f of x2 is lying above than f of x1. So this implies I can say that f of x1 is less than f of x2. Therefore, function is increasing function. Now, let us take like some points here. Now, let us call this is point x3 here, and then like this is point x4 here. After C we are talking. Now this point, if I see somewhere here, this is f of x3 and then below is f of x4. I can say that x3 is less than x4. But what is happening in function? In function we can clearly see f of x3 is above than f of x4. So it should be greater than f of x4. Now x is decreasing, but function is increasing. Therefore, it is decreasing in the interval, right? Increasing means like the first derivative is greater than 0. That means slope is positive. Tangent slope is positive. In this curve till C, you take any point on the curve, the slope at that point will be positive, right? From after C, you take any point on the curve, you will get slope as negative. That's only we will say if f dash of x is greater than 0, it is increasing. If f dash of x is less than 0 means it is decreasing. Slope is positive and slope is negative. Clear? Now, next after finding the first derivative, we should equate the first derivative to 0. Can you guys tell me what are the roots for f dash of x is equals to 0? If f dash of x is equals to 0, what we will get? The value of x. 2 times of 1 minus x square divided by x square plus 1 whole square is equals to 0. That means x is equals to plus minus 1, right? So after finding the roots, draw the number line and mark those roots. That roots are like minus 1 and plus 1. Now you need to check the sign of f dash, not for f. Let us take what is the value of f dash of minus 2? What I am doing? Less than minus 1, I am taking some value. This is 1 minus 4 into 2 divided by 1 plus 4 whole square. I don't need the exact value. What I need is positive, negative. I can see that I am going to get less than 0 here, some negative value. Clear? So like negative means writing below this less than 0. Next again I am taking f dash of 0, some value in between minus 1 to plus 1, right? If I take that, I'll get 1 here. No, 2 into 1, that is 2, which is greater than 0. That means the function is increasing function. Clear? Now again take some value greater than 1. I am taking 2 here. We have 2 times of 1 minus 4 divided by 1 plus 4 whole square. I can see this is less than 0, negative. Now, if I see from minus infinity to plus infinity, function is not increasing, right? Or not decreasing as well, but I can write by parts. F of x is decreasing in minus infinity to minus 1. That means f of x can be 1, 1 in the interval minus infinity to minus 1, right? So discarding this option. In the interval minus infinity to minus 1, f dash is less than 0 for all x belongs to the interval. Then f of x is decreasing function. Therefore, it should be 1, 1. Clear? Discarding the first option. Again, in next part of the conclusion, we can say f of x is increasing function in minus 1 to plus 1. That means again function can be 1, 1 in the interval minus 1 to plus 1. The last one is f of x is decreasing function in the interval 1 to infinity, closed bracket 1, open bracket infinity, right? So now here they are saying the third option. If you see, for third option, they have mentioned f of x is many one. That means f of x is neither increasing nor decreasing in the interval 1 to infinity. But just now we have seen it is increasing, so discarding this option. Now seeing this overall for all real numbers minus infinity to plus infinity, function f of x is neither increasing nor decreasing, therefore it cannot be 1, 1. Now the remaining is like f of x is 1, 1 in 1 to infinity, correct? But it is not 1, 1 in minus infinity to plus infinity. Dear online students, any doubts in this?
Sir, 1 minus 4 the whole square by 1 plus 4 the whole square will be greater than 0 only. No, sir.
1 minus. No. This is not whole square, ma. This is into multiplication. See, like, listen. This is f dash of x, no? Here, I am substituting x is equals to minus 2. 2 into 1 minus 4 is what I have. This is 2 into minus 3. Minus 6 less than 0. Not square, in multiplication we have.
Okay, sir.
Anything else?
Sir, why we take the graph into parabola, sir?
No, just I am explaining using a parabola. This is not related to this problem. I am explaining increasing and decreasing function by taking parabola.
Okay, sir.
Hmm. Some doubt, online students?
Yes, sir.
Where?
Sir, you have taken downward parabola. What if we take an upward parabola?
Give me a moment. I'll explain this increasing, decreasing once. I think there is little confusion about this increasing, decreasing. I'll explain in detail. Then we solve some problems. Everybody copied this part of the slide? Can I scroll down?
Copied, sir.
Vibhas, Muthuselvan. Before solving next problem, let us understand increasing and decreasing functions in detail. Madam? Everybody copied this? No response means I'll consider copied. Whoever have doubt in this increasing, decreasing, just listen. I am drawing a random graph, right? And then here we will understand what exactly is increasing and what exactly is decreasing. Let us take a function above the graph, something like this. Some graph I have drawn, y is equals to f of x graph. Now I am marking the points. This is x is equals to a c1. This is x is equals to a c2. Next, this is x is equals to a c3, right? So now I'm taking like, if I take two values, this is x1, x1 and the image corresponding to x1 calling f of x1. Clear? So now little above to the x1, this is x2, image corresponding to x2 is f of x2. So like this is positive y-axis and this is positive x-axis I have taken. Equation is y is equals to f of x. Right? Listen carefully. There are two values from the domain, that is x1 and x2. Right? x1 is less than x2. Right? From x1 to x2, I am increasing the value of x, right? Now, what is happening in function f, right? So like I can see that clearly here. What I can see here, I can see that my f of x1 is lying below than f of x2. Lying below means you can take 1 and 2 or something, right? Lying below na, if I move in this direction in y-axis, I am increasing the value of y, right? That's what I wrote here. Clear? So like I am increasing the value of x, function value is also increasing. Therefore, it is increasing function, right? Now, how to prove that f dash is greater than 0? I hope you studied in 11th grade. We can say that like f dash of x is equals to limit h, or we can say limit x is approaching c. One moment, otherwise why this much big? I can say that f dash of x is equals to slope of tangent. So slope of tangent, now let us take x1 and x2 are 2 points. First, let us find tangent slope of secant. Chord also we can call, right? So slope, if I want, slope will be equals to y2 minus y1 by x2 minus x1, right? So this is f of x2 minus f of x1 divided by x2 minus x1, right? So like if I say this x1 and x2 are very close to each other, if they are very close to each other, the slope becomes slope of tangent. Clear? Understood? Right? So now we can see that f of x2 is greater than f of x1. That means f of x2 minus f of x1 is greater than 0. At the same time, I can see that x2 minus x1 is also greater than 0. This implies f dash of x is greater than 0, right? If f dash of x is greater than 0, the function is said to be increasing function. Now this function is increasing till c1, right? Till c1, now what is happening till c1? Till c1, f dash of x is greater than 0, right? After c1, it is decreasing. It is decreasing now, f dash of x is less than 0. Now, in this process, what we are doing, we are calculating the points where f dash of x is equals to 0. That is horizontal tangent or stationary value, or we will call turning point. Clear? Understood? Online students?
Yes, sir.
Yes, sir.
Thank you for responding. Now, let us see the next problem. So this is the next problem. In next problem, they have given like, let me keep this one down. Here is the problem. They have given the domain and codomain here. So like first we will do 1-1 nature of a function. Again listen, for 1-1 nature of a function, we need to check whether the function is increasing or not throughout the domain, right? So again, if f dash of x is greater than or equals to 0 for all x belongs closed bracket or open bracket, no problem, 0 to 3, then f of x is increasing function. If it is increasing function, then we'll call it is 1-1 function. Or one more thing is there. If f dash of x is less than or equals to 0 for all x belongs closed bracket 0 to 3, then f of x is decreasing function. Decreasing function is also 1-1 function. Other than these two, any other situation arises, any other situation, I mean, f dash of x is greater than 0 for like x belongs some minus infinity to alpha union beta to infinity, and then like again it is less than 0. It is not strictly increasing or strictly decreasing. In that case, it is many one function. Clear? Now we are differentiating the given function. Given function is f of x is equals to 2x cube minus 15 into x square plus 36 into x plus 1. Now we have f dash of x is equals to 6x square minus 30 into x plus 36. Taking 6 common, we have x square minus 5 into x plus 6. Equating f dash to 0, then we will get two values, x is equals to 2 and x is equals to 3 here, right? So after equating them to 0 and calculating the stationary values or the turning points, drawing the number line, This is the point x is equals to 2 on a number line. This is the point x is equals to 3 on the number line, right? So checking the sign of f dash less than 2. So f dash of 0 is equals to 6 into 0 minus 0 plus 6, which is clearly greater than 0, writing positive here. F dash of, like, in between 2 and 3 I need to take. Let us take 2.5. This one I can write like 6 times of 2.5 minus 2 into 2.5 minus 3. So like I can clearly see that it is 6 into negative value and then positive value. I got negative here, right? Now the next one, greater than 3, let us take 4 here. F dash of 4 is equals to 6 into, we have 16 minus 20 plus 6. I think we are having positive again here, right? So that means the given function, right? Maybe they are not talking entirely in the real numbers. If they are talking entirely in the real numbers, I can say that f dash of x is less than 0 for all x belongs open bracket or closed bracket 2 to 3. This implies f of x is decreasing function in 2 to 3. Therefore, if the interval is 2 to 3, I can say it is 1 1 function. Clear? So like one more thing I can write here. Like next thing is like f dash of x is greater than 0 for all x belongs 0 to 2 union. Maybe this one will do. They are asking in between 0 to 3 only, no? This implies f of x is increasing function, right? If this is an increasing function in the interval 0 to 2, it is again 1 1, right? So if I'm trying to draw the graph, like doesn't matter from where it starts, from where it will go, right? F of 0 value is 1, like somewhere here it starts till 2. What it is happening, it is increasing the values, right? From 3 onwards, it started decreasing. Somewhere here it will reach. This is x is equals to 3 line, right? Now, if I draw a horizontal line somewhere here, this horizontal line is intersecting at 2 points. That's why it is said to be many one function. Clear? Understood? Huh? No, like you can see now in number line. In number line, in between 0 to 2, it is positive. Therefore, it is increasing function. Increasing function 1 1. Clear? So, if from 2 to 3, it is less than 0. If it is less than 0, it is decreasing function. In two different parts, if they ask this one, 0 to 2 and 2 to 3, I can say that it is 1 1. But they are asking entirely. In the interval, given interval, if function is both increasing and decreasing, that cannot be 1 1 function. Clear? Any other doubts, online students?
No, sir.
No, sir.
You can copy this one. This is like section G problem. 1 1 nature we proved it is not 1 1. So which options to discard? Option 1 and option 3 got discarded. Only 2 and 4 that we can discard only if we find about onto nature. That means we have something about the range, right? So like let us do for the range, guys. Pay attention. So I am concluding here. Therefore, f of x is many one function in closed bracket 0 to 3, right? So now here I am using a method called absolute maxima and absolute minima to find range. What this method says? This method says let's say function f is defined in closed interval a to b. Codomain can be anything. You can write real numbers, right? In this case, to calculate range, we use this method absolute maximum and absolute minimum. In this method, step number 1 is calculate f dash of x and equate that one to 0, right? So this is first step, and then step number 2 here is like take only such values of x. Let's say here x is equals to C1, C2, C3, and so on going till n values you have where f dash is 0, right? So then out of these n values, you pick only those values, right? Let us call C1, C2 belongs to closed bracket A to B. Just consider the values which belongs to the given interval. Remaining it won't matter, right? Now in third step, now we should calculate the value of f of a and then f of a c1 after that, f of c2, the last is f of a b. After calculating these all things, right, a range of the function will be equals to, a range is equals closed bracket minimum between f, right, minimum of f of a, f of c1, and so on going till f of b. Like how many you have in that, minimum will be your minimum value, and then maximum will be the maximum value in the given interval, right? So this technique is called as absolute maxima and absolute minima to calculate minimum and maximum value. This is NCERT of 6th chapter, applications of derivatives. Now I already did the step number 1. I differentiated and I equated to 0. I got two values, x is equals to 2 and x is equals to 3. Both belongs to the interval, right? Now, what we need to do, like next we need to do f dash of x is equals to 0 we did, and we got x is equals to 2 and x is equals to 3. And then given interval is 0 to 3. Now the value of f of 0 and the value of f of 2, the last is the value of f of 3, right? So can you guys tell me what is f of x so that we can calculate f of 0 and all? It is 2x cube minus 15x square plus 36x plus 1. I can see f of 0 value is 1, right? F of 0, the moment we put 0, we have 1. Next, f of 2 we need. This is like 2 into 2 cube is 8 minus 15 into 4 plus 36 into 2 is 72 plus 1 here. 16 minus 60 plus 73. So we have 16 plus 13, this is 29, right? Now the last one, f of 3 we need. F of 3 is like we have 2 into 27 minus 15 into 9 plus 36 into 3 plus 1. How much is this? I think this is 54 here minus 135 here. 36 into 3 sounds 108 here, right? Last is plus 1. Now if I add all positive things, 108 and then 54. So this is like 12, 163 minus 135 I need to do. This is 5, 8, 28. So I have three values. Right now I am considering minimum out of these three will be how much, guys? Range of f of x. We are writing minimum out of these three is 1, right? So maximum out of these three is 29, right? Now the given codomain, if I observe the given codomain, I'm seeing carefully, that is 1 to 29. If codomain is equals to range, then the given function is onto function. Clear? Understood? See, like till now, we are mainly concentrated on 1. We are trying to understand how we will do using calculus approach. Calculus
Sir?
approach, yes, please.
Sir, can we take the cubic method, sir?
Cubic method. What do you mean cubic method?
In the previous problem, you used the cubic
See, like
method.
that one you use when they have given function is mapping from a real to real In that
Oh.
case, we can close our eyes and we can say the range is minus infinity to plus infinity. But like here, the given domain is 0 to 3. When domain is restricted, range will also have some restrictions. Clear?
Okay.
Any other doubts? Online
No, sir.
students? Then copy this one. Scroll down. Online students scrolling down. See this increasing, decreasing, absolute maxima and absolute minima. Appliance of derivatives NCERT concept only. Not difficult at all. All copied this. Can we move to the next problem?
Yes, sir.
Okay, all done. Moving to the next problem.
Yes, sir.
One moment. See, like, there is a problem given here. One moment. I'll copy and paste in some other slide so that it will be better for you. I suggest everybody who is attending this class, give one try and tell me whether it is a 1-1 function or not. What I am guessing here is like the given function is most probably not 1-1. Not sure. This is just my guess. I think everybody can see this is the given function. Plotting graph and all don't do. It is difficult. What I suggest you to do here is like go differentiation method. In differentiation method, there are three main steps. Step number one, calculate f dash of x and equate that one to 0. Step number two, right? Draw the number line and identify where f dash is greater than, f dash is less than. After identifying, last and important step, conclude whether it is increasing or decreasing. Clear? So anybody has the answer? No response from online guys. Do you guys know U by V rule of differentiation? Online students?
Yes, sir. Doing, sir.
Yes, sir.
Yes, sir.
Okay. If you don't know, I'm writing here. Dash stands for derivative. So dear students, this is what I got as a first derivative. So anybody else got different one? If you identify any calculation mistake in my calculation, just let me know.
Correct, sir.
Correct, super.
Correct, sir.
Hmm. So we calculated first derivative. Next, equating that to 0, we need to do no? Okay, let us equate the first derivative to 0. The moment we equate this to 0, I'm just writing the equation x square plus 4x plus 1 equals 0 will be remaining. Remaining all doesn't matter, goes to another side. Now, roots of this equation. Do we have real roots for this? X square plus 4x plus 1 equals 0 has real roots or not?
No, sir.
No, hey, real roots are there, no?
Real roots are there, sir.
Sir, it
That's
is
what?
not 1, sir.
Not 1 only, correct. So two roots are there, guys. Let us call them as alpha. Alpha is -2 minus root 3. Another root is beta. Beta is -2 plus root 3. Approximate value of root 3 we can use for this problem as 1.7. So -2 minus 1.7 is -3.7. So this is minus 0.3. Why this approximation? Next we are going to draw a number line, no? This is the number line we drawn. This is alpha here. This is beta here. Take any value less than alpha. For example, -4 we can take. Calculate f dash of -4 sign, not value. Sign is what we need. F dash of
Positive, sir.
-4, positive or negative? 16
Positive, sir.
check again.
Positive only, sir.
Positive only. If you got same first derivative, you should get negative. Decreasing function. Check no. I'm getting negative here. Anybody else?
Sorry, sir, I used
Yes,
that simplified equation, sir. For
Don't
substitution.
use a simplified equation. Please use given exact f dash. Next f dash of like in between 3 minus 3.7 and minus 0.3 there is -1. Use that. So what is this value over here? Positive or negative, guys? F dash of -1.
positive.
Positive. Automatically take 0. F dash of 0 is equals -3 into 1 by 1 square. This is negative. If they have given the domain of the function as -infinity till alpha, then it is 1 function because it is decreasing in the interval. Or else, if they have given alpha to beta, again it is 1 function, right? And then beta to infinity also 1. But all together, if I see, right, function is not 1. Clear? Understood? Any doubts in this? F is many one in R. That means a set of real numbers if we take, that is many one. Dear online students, any doubts in this problem?
No,
No,
sir.
sir.
Thank you for responding. See, like there are few problems like this, the model problems. You can try this one, the highlighted one. 1.51 is there now. Note it down as a homework. Try at home. There are some problems in our book where they are asking 1 onto nature. One exercise will be there. Try that exercise. 1.61 I'll teach. This is exercise problem only, 19th one. Example 15 also I'll teach. Tomorrow again 4 o'clock we will schedule one class. At that time again we will be having some 1 hour, 1 hour 20 minutes class like this. Tomorrow we are continuing with the same thing. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you for responding. So like just note it down this problem 1.51 try once. Not now, maybe you can try at home. You try whenever you have free time and then please try to solve this exercise based on 1 and on 2 nature of a function. After solving, we can see the problems little later. Tomorrow class, maybe I'll finish this 1 on 2 and we'll enter domain and range as well.
Sir,
Yes, please.
sir, in this problem we use both the method, sir.
Which one?
The analytic-
1.51.
Yes, sir.
That not required. Just use differentiation method.
Okay, sir. Thank you, sir.
Huh? 1 function only two. Remaining we'll see in that f of x1 equals f of x2 method. We assume x1 and x2 are two values, distinct values. Then if f of x1 equals f of x2, then x1 should be equals x2. Right, okay then dear online students, we'll see in today's maths class. You can leave for this.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.